Continuing our conversation this morning on the future of technology and the quest. We all want to live a little bit longer. If not, I know Joe wants to live forever. Craig Venter is here. He's the CEO of technology-driven genomics company Human Longevity, co-founded by our guest host, Peter Diamandis. Dr. Venter is also known as one of the first scientists to sequence the human genome. Good morning.
Good morning.
So how close are we, or how far are we away?
Well, we're learning that we're a DNA software-driven species, and that your software determines everything about your life, including how long you're going to live. So if you're a male between 30 and 74, 30% of you will not reach the age of 74. Some of that's due to cancer and heart disease. But now that we've sequenced over 30,000 genomes, we're doing one on average every 15 minutes, we're finding there's errors in the genetic code that disappear out of the population at different ages. In other words, people with those errors die.
So the question, though, is, given new tools like CRISPR and other things like that, are you going to be able to rewrite people's genetic code that are currently alive, or are we going to be doing this effectively to create designer babies that will live longer later?
So I think that's the same fantasy that we had about 20 years ago with gene therapy of, you know, how do you get the right changes in 100 trillion different cells. So, no, I think all these targets we're finding are going to be new pharmaceutical targets of how to change them so that the people with those genetic changes don't die. It's one of the most surprising findings we found, just looking at the whole genome on billions of data points. Just certain markers disappear early on from the population. And they're all heterozygous, which means it's just one copy of a gene is enough to have you have a shorter lifespan. And these are all new targets, new biology that we haven't seen before.
But people live old enough to put them back in the gene pool, unfortunately.
They do, because that happens very early on.
So that doesn't help. So we cure cancer and heart disease. We're still going to die of old age. And what have you found out with all the great work you've done over the past 20 years? What's the most novel, or what was there an aha moment yet about trying to figure out aging for you?
Well, the biggest surprise, if you'd asked me 20 years ago when we talked about the human genome,
which we did,
I would have said you get sequenced once and that's good for the rest of your life. I think the biggest surprise we found early on is it's changing every day, and we can actually predict your age from sequencing your genome. So we're exposed to radiation, we're exposed to chemicals, so we're fighting a kind of a losing battle of just changes across the entire code.
Have you completely gotten rid of all the superfluous DNA that's structural or regulatory and gotten it down to how much is actually coding for gene products? Is it 2%?
We did that in a simple bacteria. That's what we announced our first synthetic cell. With the human genome, most of the discoveries we're making are outside of the gene areas. So the rest of the genome, other than does do really important stuff.
Craig, talk a little about what HLI is doing with the health nucleus in terms of revolutionizing healthcare.
Yeah, so we're not just sequencing the genome. We're combining it with all these tests of MRI imaging, DEXA, CT scanning. And for people that are coming in, everybody that comes in, they come in healthy. But 40% of them we're finding major disease in. But the difference is we're finding cancer at stage 0, stage 1, sometimes stage 2, where it's totally treatable. In contrast to what we get through our comprehensive cancer program, we have 3 women right now in their 30s with stage 4 colon cancer. So it's really satisfying when we discover it before it's spread, and it's 100% treatable versus what medicine does now. You detect it once you have symptoms.
You walk into the hospital and you say, oh my God, I've got this, but it didn't happen that morning. It's been going on for months or years.
Yeah, we get 1.3 million new people with cancer each year. Some of them have had it for years.
And you're finding this just as a function of sequencing their DNA?
It's a combination of the sequencing, the MRI imaging, and some of the other tests we're doing. It's absolutely stunning.
For each different cancer, there's a different marker for that first mutation that leads down the road.
Well, some of us have genetic risk for cancer.
Right.
Cancer is probably 50% directly inherited cancer, and the rest is from environmental changes. But we're making discoveries in heart disease. I mean, things across the board. So it's the most comprehensive physical you can get. And thus far, everything we found has been actionable. It's been treatable.
What's the cost of that physical, if you will?
It's not cheap. It's $25,000.
And a day in La Jolla.
And a full day in La Jolla. And it generates close to a petabyte of data. So it's not trivial either on the
Which, by the way, we have a machine learning team there run by Franz Acker on Google Translate that does the analysis of that data in a way that no human doctor could ever do.
So you look out 5 years from now, DNA sequencing unto itself now is down to what, about $1,500, $1,000?
Yeah, about $1,000 when you do it at the high throughput level we have. So it's sort of a trivial cost compared to the rest.
Well, on the whole, though, how much more expensive is it to live much longer than we do as a society currently?
Well, when you look at the cost of medical care, which you guys have covered going up double digits forever, if we convert it into a preventative medicine program, these people we're finding with stage 0, stage 1 cancer. One gentleman, it was mid-50s, came in. He was going to go on a European vacation the next day. We found a large tumor under his breastbone. A week later, he had it surgically removed using the MRI data that we had. So as far as he knew, he had cancer for a week. A week later, he was cancer-free.
How many different cancers are you able to detect with this 25,000? There's some that you obviously aren't able to detect.
We wouldn't detect blood cancers, for example, with the imaging techniques, but we would with some of the DNA sequencing.
But with the DNA techniques, how many cancers do you think you got covered? How many are there?
Well,
500
we predict cancer risk, not absolute cancer. So what we do,
MRI, you see the actual mass.
That's right. We do the unique of combining the DNA with the imaging.
But you've got two approaches to addressing cancer right now at HLI, I think, that are probably revolutionary, that are worth it.
Yeah, if you have cancer, we sequence the DNA in the tumor. We isolate the T cells from the tumor, and we can give those back to the patient. We can develop cancer-specific vaccines for that patient.
Given the cost, if you can afford it, at what age would you actually do this test?
So you can't do it too young because somebody has to be able to tolerate an hour in the MRI machine, so young kids aren't great at that. We predict your face from your genome at roughly age 18. So I think if you come in probably early 20s, early 30s, it creates a baseline for you for the rest of your life.
And if you look out 5 years from now, the cost, this $25,000 cost comes down to?
Well, the cost is imaging. It's the cost of all the technicians, so it's not clear how much.
It's not clear that, so we might be, it doesn't become that much more scalable.
Sequencing will be close to free in the near future.
It's everything else.
It's everything else. These are not cheap machines, but we have a version of it that we think we can do for less than a few $1,000s. The two most important things are getting your genome sequence combined with MRI imaging.
Right.
Because now with the new MRI imaging, we can detect and diagnose cancers without any contrast media at all. So the changes just in the last 2 years in MRI imaging is something. So
real quick, is there any argument to be made that people are going to go and do surgeries that they don't necessarily need to do as a function of this?
So that's the myth from like 20 years ago when CT scans and things first came out of, the incidental omas.
Right.
Now with the new imaging, we can diagnose prostate cancer just straight from the MRI image versus benign prostate growth. So the technology has changed to really eliminate that problem.
If people want to learn more, where do they go, Craig?
So humanlongevity.com or thehealthnucleus.com. Come spend a nice day in La Jolla.
Very cool. Thank you. Craig, great to see you. It's pretty awesome.
It's amazing. We're going from a world where healthcare is sort of retrospective. You get it when you're at end stage to when it's predictive and preventative and personalized. It's your genome tells you what you're going to come down with.
We appreciate you bringing this conversation to us this morning. Thank you both.